So one of the questions on the survey is, if I were to buy a book to start myself off, what would it be? And I suggested this one for 3 reasons, maybe 4. Jimmy Akins is a Catholic scholar. This is from Catholic Answers. You can get it at Barnes & Noble. You can get it on Amazon. The first reason I would suggest this book is there's 366 one-page little essays, if you will. So you can easily find the subjects that interest you. The second reason would be that you can find the topics that people have asked you questions about and you feel stuck because you don't really know an answer. And number 3, I would say is the most important. We don't know what we don't know. Until I started studying this, and I'm actually auditing part of a master's course on this and getting a certification in Christian apologetics, there were so many areas of our faith that would have never occurred to me. So I think this book is really interesting in that way. It's a nice cross-section, very Catholic. So we'll start now. We're going through the book, The Reality of God by Stephen R. Hemler. I've talked to Mr. Hemler. Oh, there's our dancing bears. All right. So whoever wanted the dancing bears, there they are. I've spoken with, communicated with Dr. Hemler. Nice man. He even offered to come and speak until he found out we were in Cleveland. He's on the East Coast and he lives near Connecticut or Maine or something like that. And he said it's just a little too far for him. So as I said in previous weeks, please do not take this stuff too seriously. We're just one teeny little speck on a speck in a bunch of specks. And it's really for God to be able to wrap his mind around all those things. We're just here to really become saints. It sounds a little over the top, but we all have a purpose. God wants us to fulfill it, and that's how we become saints individually. And as I said last week, treat this information like a crossword puzzle. If you get a few going across, but you can't figure out the downs, wait till you get the across filled in, and maybe you'll have enough letters to figure out that other clue. And if you don't, put it up on a shelf. I've been studying this for years, and believe you me, it doesn't come overnight. Once again, I talked about how this book has the nihil obstat in imprimatur, which means the Catholic Church has had someone with a sacred theology doctorate go through it and see that there's nothing conflicting with faith and morals, and that a bishop signed off on it saying, let it be printed. But I want to be very clear, it does not mean that what's in this book is touted or believed by the Catholic faith. It just says it doesn't interfere, and that you are allowed as a Catholic to make your own decision because the Church has no poker in the fire on this. So we'll say again, what is apologetics? The quintessential verse is 1 Peter 3:15. Always be prepared to give an answer, apologia, to everyone who asks you to give the reason for the hope that you have. So we actually have a command not only to go out and make disciples of all nations, but we have a command that says we're supposed to have a reasoned and ready response for the reasons why we're Catholic. And throughout history, all the way until the Age of Enlightenment, that was a very obvious thing in the Catholic faith. And since then, we don't want to offend anybody, and your truth is your truth, and my truth is my truth, which is not true. So we don't want to offend anybody, and apologetics has sort of fallen out of favor. It is the root word of apology as we know the word today, but it didn't mean to apologize. It was akin to a legal term meaning to defend in an intellectual way. We give rational replies. We never apologize for our faith. It's also means a ready response, a reasoned answer to the faith that's within us. It also means a verbal defense, which puts some people off. I've had people ask me, what do we have to be defensive about? And that's not what the word means. It's taking the views handed to us by society at large and dismantling its unfounded and mistaken beliefs. They abound. We know that. Our kids hear them. The internet is just proliferated with them. So if you remember the acronym DUMB, you might remember that we dismantle unfounded and mistaken beliefs. This is hopefully how the schedule goes. We got started 2 minutes late, so we're pretty darn close. We'll have the talk, then we'll have the group discussion. Then at the end, if there are any questions, we'll wrap up with that. And there's the fine print. All times are subject to change, so depending on what happens that week, we'll just roll with it. During this presentation, ask yourself what difference this information can make in your life personally, where you might see God's overarching design with new eyes. I'm going to point out a few after this presentation is over, where this information might create an opportunity for you to share your faith with others. And might this talk show you more how much God loves you, because all of this was created with you in mind. This chapter of the book, The Architect of the Laws of Nature. Okay, this chapter of the book, The Architect of the Laws of Nature, didn't have a lot to speak of. It was a lot of formulas, and this book is touted as being a layman's guide. Oh my goodness. I've had classes on this stuff, and I didn't find it interesting. So I did a little adjusting. The good news is I won't be talking a lot because there's going to be a phenomenal video. The bad news is you're still going to hear a lot, and it's going to be a little bit about math, but nothing like Einstein's equation or Newton's equation for gravity. And in all seriousness, the real good news is, like I said, this is one of my 8th grade's favorite classes, so I hope you enjoyed as much as they did earlier today. We have to remember that science can never eliminate the why question. For instance, why are there laws of nature, or even why can we understand them? This author, Stephen Barr, who penned Modern Physics in the Ancient Faith, wrote, "The harmony, order, and elegance found in the governing principles of the universe, based on mathematical concepts that take the greatest effort of the finest minds to unlock and understand, must have come from a mind far greater." He's an astrophysicist, so I'm in his boat. I agree with him. So this man is also phenomenal. His name's Freeman Dyson. He's professor emeritus at the Advanced Study Institute at Princeton, so he's a pretty sharp guy. He's got a bunch of things named after him that I have no clue what they are. So he's one of those guys that's spooky smart.
And of course, all these questions about God and about the nature of consciousness and so on, these belong to the mental world. And I don't think we're close to understanding them. Einstein sort of was the prototype of a scientist who sort of worshipped nature as his God, and he thought of the laws of physics as sort of being, in some sense, the God that he worshipped, and the majesty of the universe he saw in the laws of physics. I don't go along with that. I mean, I think the laws of physics are fine as far as they go. There's no reason to imagine that that's all there is. And we have certainly a lot of evidence that there are mental things which are outside the scope of physics, but we don't have the tools really to grasp them. I prefer that the laws are independent, that the mental world has its own autonomy, but then, of course, that's my prejudice. God may turn out to disagree with me, as he often has in the past.
So not only is he spooky smart, but he does believe in God. He doesn't use the word religion. He doesn't use the word metaphysics or any of those others. He just talks about the mental aspect, and over the years he's seen so much that he knows there's much more beyond the mathematical and scientific side. So this is where you have to hold on to your socks. This is the beginning. It's a little scary in the beginning, but this is where it starts, where the 8th graders and the people this morning really started to dig into this.
Okay, but it will blow your socks off. This is very cool stuff. And there is absolutely no secular or evolutionary explanation for what I'm going to show you tonight. I'm going to give you a little window into the mind of God. How's that for an opener, huh? All right, so let's get started with the secret code of creation. I do have to start by saying that when I was young, and my mom would prepare these wonderful meals, but sometimes she'd prepare something I didn't like very much, like broccoli, for example. And the rule was you had to eat everything on your plate, before you get up. And sometimes in moments of maturity, I would eat the broccoli first so that I could then enjoy the rest of the meal, right? So in that spirit, we're going to do the broccoli first. Okay, but stay with me. It's going to get cool, okay? Just stay with me. There is a secret code that the Lord has built into numbers. We don't think about God creating numbers. We think about him creating mountains and rivers and people, but you see, God is also sovereign over the abstract world of thought as well. And he's sovereign over mathematics. That's his language. And I want to show you the secret code that he's built into it, and it's incredibly beautiful. You're just gonna be blown away by this. It's amazing. To start out with our broccoli section here, we need to talk about sets. A set is just a collection of elements, in this case numbers, that have a certain property in common. It's very simple. So a group of numbers that have a certain property in common, and in most sets, some numbers are included and other numbers are excluded because they don't have that common property. And just as a few basic examples, it's getting stuck here, isn't it? There we go. So let's see. Come on. Consider the set of even numbers. There we go. And so those numbers belong to the set, and the other ones do not belong to the set. That's pretty easy. No problem there. And so that's a particular set. We could consider the set of negative numbers, and that's a different set, and so different numbers will belong to it. Yes, some numbers are included, some numbers are excluded. Now, those sets are very easy because you can tell just by looking at the number if it belongs or not. You know if something's divisible by 2 or not. You know if it's negative or not. It's got the minus sign in front of it. That's pretty easy. Some sets are a little more complicated, and you can't tell just by looking at the number whether it belongs or not. You're going to have to do a little bit of thinking first. And so we're going to spend our time talking about what's called the Mandelbrot set. The Mandelbrot set. And it's defined a little bit more complexly, but just like any other set, some numbers belong in it and other numbers are excluded. The Mandelbrot set is the set of all numbers, which we're going to call C, lowercase c, for which this other number, z, remains small according to this formula. And I know this looks very complicated. It's not. I'll take you through it. So there's this little formula here, and z is a number, and it starts as 0. And the n means that there's a sequence of z's. There's z1, z2, z3, z4, z5, and it's just a sequence of numbers like 1, 5, 7, whatever. And if that sequence remains small, then this number we're checking, C, is part of the Mandelbrot set. On the other hand, if the sequence of Z gets very large, then C is not a member of the Mandelbrot set. Again, sounds complicated, so we'll do a couple of examples here. Is the number 1 part of the Mandelbrot set? So in this case, C is 1. And so we're going to plug that into our little formula. And Z always starts as 0. And so our first iteration here, come on. Bill Gates puts anti-creation software on these things. I'm telling you. There we go. Let's get a virus on there or something. All right. So our first Z is 0. That's all. That's the rule. It starts as 0. And so we have 0 squared plus 1. 0 squared is 0 plus 1 is 1. That's pretty easy. And so that's the new value of Z, you see. And so we're going to put that 1 back in. Okay, that's the new value of Z. So now you have 1 squared, which is 1 times 1 is 1, plus 1 is 2. Okay, I told you this was easy. It's not hard. Okay, 0, 1, 2. Now we're going to put the 2 back in. Yes, 2 squared is 4, plus 1 is 5. Okay, yeah, you got that. We're going to put that back in. 5 squared is 25, plus 1 is 26. Going to put that back in. 26 squared is big. Okay, so you see what's happening with the sequence of Z? It's getting bigger and bigger and bigger. So is 1 part of the Mandelbrot set? No, because remember, Z has to stay small for C to be part of the Mandelbrot set. So C equals 1 is not a member of the Mandelbrot set. So we found that it does not belong, but it wasn't simple. You can't tell just by looking at it. You got to run it through that little formula. So let's do another one here. Come on, computer. Is the number 0 part of the Mandelbrot set? So this time C equals 0. We're going to put that in to our formula. So Z squared plus 0 is the new value of Z. So the first value is always 0. It starts as 0. So we're going to put 0 squared is 0 plus 0 is 0. Okay. And put that back in. 0 squared plus 0 is 0. Okay. Put that back in. Yeah. So you see what happens there? It just gets You just get more and more zeros. And so does Z stay small? Yes, it does. And so is 0 part of the Mandelbrot set? Yes, you got it. Easy. Tedious, but easy. Okay, one more, because I know this gets old after a while, but let's try -1. Is -1 part of the Mandelbrot set? So now we have Z squared minus 1 is the new value of Z, and Z always starts as 0. So we'll put that in first, and we'll have 0 squared minus 1 is -1, yes. And so that's our new value of Z, and we put that back in. -1 squared is +1, minus 1 is 0. Okay, we put that back in. 0 squared minus 1 is -1. Okay, you see what's happening there? 0, -1, 0, -1, 0. So it doesn't center in on one number, but does Z remain small? Yep. So is -1 part of the Mandelbrot set? Yeah, you got it. Easy. There's one more complication, and then it gets really cool, okay? The Mandelbrot set also includes the so-called imaginary numbers.
I had a NASA scientist in the group this morning. He's part of our parish. When he heard that, he goes, "Oh no, Shane, you're not going to do that, are you?" I cut it off, but I did want to put that little scare in there. So who is Dr. Lisle? Dr. Lisle is an astrophysicist. He earned his undergraduate degree from Ohio Wesleyan University, so he's one of ours, summa cum laude, with a double major in physics and astronomy, and he threw in a minor in math. He's credited with discovering some things with the Hubble telescope. He's widely published. He's super smart, but if you look at the PS at the end, this is what really cracked me up. At the end of the article, it says, and he has also published numerous papers in legitimate scientific journals. Because anything he says that might point towards God or might have some other view, they don't count that, and he's had papers refused from legitimate journals.
There's no pattern that I can see. And so perhaps what we could do then is we could plot it on a graph, right, with the real numbers representing the real component of the x-axis representing the real component and the y-axis representing the imaginary component. And so all the numbers we check. I'm exploring the shape because the thing that I want to get across to you is this is not a shape that people made, right? This is a shape that is built into numbers.
This is what was plotted.
All this is a plot of which numbers belong to that Mandelbrot set. That's all it is. And it turns out to be wonderfully interesting. We're going to zoom in on sections of it here in just a second. The upper portion here, you can see that this top sphere branches off into 3 branches, right? A stem and 2 branches, so 3 total. That's kind of interesting. The one next to it branches off, I don't know if you can see that, but it branches off into 5 branches. Can you count that? Can you see that? The next one, they're getting small, but it branches off into 7. And the next one, 9, 11, 13, 15, all the odd numbers, all the way down to infinity. Odd infinity, apparently. Whatever that means. On the other side, you get all the numbers, including the evens and the odds. Interesting in terms of the way they branch. Isn't that fascinating? So it knows how to count somehow, which is wild. And perhaps even more interestingly, 5 plus 3 is 8, yes? Right? And the little shape in between them has 8. And that's always the case. Whenever you check the bud in between 2, it adds the number of stems. No matter which one no matter where you're at. So again, 3 and 4 is 7. That's how many it has. 4 and 5 is 9. That's how many it has, and so on. So somehow it knows how to add. That's kind of neat. Just amazing. Incredible shape. Okay, we're going to spend some time exploring this. And one thing I want to check out is this little that spike there on the end. You see that spike? Because it's got a little black spot on it. What could that be? Well, let's find out. We're going to zoom in on that little thing. Oh, isn't that interesting? It's a baby version, right? It's the same basic shape as the parent. It's got the cardioid, and you got the little circles growing off of it. It's not identical, It's very similar, but it's not identical. It has extra spikes growing off of it. The parent didn't have these. They're very faint, but the parent didn't have these extra spikes growing off of it. So it is, and it's got a baby. Oh yeah, how about that? And on the, of course, on the tail of that is another one. Let's see if I can go to that one. How about that? And you could do that forever, literally. Yeah. There it is. And every time you get, we zoomed in on a spike, and the baby version has more and more spikes as you zoom in. So it inherits the property of the section of the parent that it grows off of, apparently. So all that on a tiny little section of a tiny little section of a tiny little section of the Mandelbrot set. And if you're wondering, there's nothing bigger. That's the ultimate one right there. There's nothing outside of it, interestingly. Other places we can go exploring. They call this the Valley of the Seahorses. Can you see the seahorses? By the way, the colors are arbitrary. We can make those whatever we like. But the shape is something that God has built into numbers. That's what you need to keep in mind. This is not a human artist that made this. The computer helped us plot it, but the shape is built into numbers. This is just the shape you get when you plot what points belong to the Mandelbrot set. See the seahorses over there on the right side? They're upside down, and they're a little dark on the screen, but they really do look like seahorses. It's kind of amazing. So let's go off to the right here. We'll zoom in a bit on one of these seahorses. Now again, all you're looking at is a plot of which points belong to the Mandelbrot set, and it turns out to be wonderfully complex and beautiful. Isn't that amazing? God has built this shape into numbers, hidden there for nearly 6,000 years, and human beings discovered this in the 1970s and actually 1980s. How about that? It was waiting there for us, but there it is, built into not the physical world, but into the abstract world of mathematics. Amazing. And I should point out too, remember the points that are very bright are points that are very close to being on the Mandelbrot set, but aren't quite on it. And so that tells you everywhere you see one of these bright points, it's actually close to a black spot that's actually part of the Mandelbrot set. It just gets so thin you can't see the black anymore. It's like a thin wire that wiggles around. It's just incredibly wiggly, you see. And in fact, mathematically, it's as wiggly as it can possibly be in 2 dimensions, if that means anything to you. Which it really doesn't to me, but anyway. Now, I found from experience, you can zoom in on the center of that until your heart's content and nothing really changes. It just keeps going forever. Little window into the mind of God, because that's how God thinks about things. He's infinite. And this gives us a little taste of that, doesn't it? Just a little taste of it. So I thought, well, let's go off axis then. Let's see what these threads are made of. And we have this beautiful spiderweb type structure. And I want to see what the threads of the spiderweb are made of. Yes? So let's zoom in to one of those. And they're made of more spiderwebs, smaller spiderwebs. How about that? And here you have you got the central hub of that spiderweb, and you got another one up there, and they intersect in the middle. And there's a little black spot there. Let's zoom in on that a bit. Oh, how about that? Isn't that interesting? You got a feeling like God really likes that shape or something? It's built into math, built into numbers. And again, it's not identical to the parent. The main shape is, but it's got extra stuff growing off of it. We zoomed into a spider web, and it's got extra spider webs growing all the way around it, you see. And you might notice it's got a little baby version too. It gets computer intensive to zoom in too much though, so we'll go back out here. But all of that's in a tiny little section of the Mandelbrot set. That's what it is. Isn't that phenomenal? Well, let's explore. Let's go back to that valley. We went off to the right last time. Let's go to the left this time. They call it the Valley of the Double Spirals. And so you see those shapes there. As we zoom in a bit, it'll be easier to see. They're double spirals, and by double spiral, I mean it's got 2 strands that interleave together. If you follow this strand around right here, it goes around like that, comes in, and it's right here. There's one in between, see? This strand and this strand are the same. This strand and this strand are the same. So it's 2 strands wrapped around each other, a double spiral. And again, I found you can zoom into the middle of that forever, and it just keeps going. It's infinite. And so let's go off axis and look at one of these strands to see what they're made of. And they're made up of, well, spider webs and more of these double spirals. And we have a new structure in the middle. I call them a bow tie. Doesn't it look like a bow tie right there? Kind of. So let's zoom in on that bow tie a little bit. And it's made up of two double spirals, and they intersect in the middle. And then 2 becomes 4. You see 4 in the middle. It's kind of a cross structure. That's kind of pretty. And then 4 goes to 8. Oh, you were expecting it this time, weren't you? Yeah. How about that? Once again, you got the baby version of the Mandelbrot set built into itself. Phenomenal. And they think about it, you can see the little spike there, it's got a baby version of that. You could zoom in onto that, you could zoom in on the Valley of the Seahorses on that one, and it would just keep going forever. It has an infinite number of babies built into each baby. It's remarkable. And incredibly beautiful. I get to pick the colors, but the shape is God's. Yeah. Well, I wanted to see what else this thing has to offer, so let's zoom in on some other sections. Let's zoom in over here on this cardioid shape, and this they call the Valley of the Elephants. Mathematicians like to make up fun names for these things, but it really does look like elephants, doesn't it? See the elephants marching along in formation, the trunk there, and it's all curled up. So isn't that interesting? We'll zoom in on the trunk here of this elephant, and this is a single spiral, not a double spiral, so it's just one strand. And let's zoom in on the threads of that. And again, you can zoom in, any spiral you zoom in on, you can zoom in on it forever, and it'll continue. We got now spider web type structures. We got single spirals, and now we have bow ties again, but now the bow ties are made up of single spirals. So it's interesting, whatever part you zoom in on, it kind of inherits the properties that you're zooming in on there. Is that not stunning? It goes from 2, and then in the middle there, you can see 4, and 8, and 16, and 32, and 64. See? And once again, you got a baby version built into it, so you can't escape that, apparently. Just remarkable. And just to think about what we're looking at. I mean, it's one thing to say, well, that's very pretty, but it's another thing to think about what you're seeing. You're seeing a map that God has built into numbers. That's what we're seeing. A little window into how God thinks about numbers. That's what it is. That's why it's beautiful. It comes from God. There's no secular explanation for this. I'll talk more about that later on, but there's something to process. There is no secular explanation for this. Let's zoom over here on this valley. This is the one valley over, and they call this the Valley of the Scepters because it looks very similar to Seahorse Valley, right? You got seahorses over on the right and double spirals on the left, but now they have scepters growing off of their foreheads. You see, they're sea unicorns now. And so I thought, well, let's zoom in on one of those guys. And since we haven't seen a scepter before, I thought that might be fun to zoom in on. It's just fun to go exploring in this shape, and it's an aspect of creation that we've only been able to explore in the last 30 years or so. Because even though it's been built into math from all eternity by God, it's only something that we've had computing power to be able to explore recently. You could theoretically plot this by hand, but it would take forever. Okay, so you zoom in, there's a cross structure in the middle, and again it goes from 4 to 8 to 16 and 32 and 64 and all the way into another baby Mandelbrot. Anywhere you see intersecting structures, I've sort of learned where to look to find them now, but anywhere you see intersecting structures, you'll get a baby Mandelbrot right in the middle of them. Incredibly beautiful. Here's another interesting tidbit. Physical fractals. We've looked at abstract fractals, right? That exist only on computer screens after we map them. But their true fractals repeat infinitely and are only found in the conceptual world of mathematics. We can represent them with physical plots, but they only exist actually in the mind of God ultimately. But the physical world also contains many things which are approximate fractals. They don't repeat forever, but they repeat many times. And so let's take a look at some examples of these. Snowflakes have a fractal quality to them because it's not that they repeat exactly, but they have the same basic type of shape, that six-fold shape, no matter how much you zoom in on them. So they repeat approximately, these little gems from heaven that God sends us every winter, and they're just stunningly beautiful, and they do have that fractal property to them, the six-fold shape being determined by the oxygen molecule and so on. And that stuff that forms on your windows, yeah, that's a fractal too, because it tends to repeat on smaller and smaller patterns. You can't tell immediately by looking at it how big the scale is. It's scale invariant. And quite lovely, really. I was always amazed by this when I was a child, looking at the window. I'm still amazed by it. Look at the window and you see these beautiful patterns that form on there. They're fractal. Ferns have a fractal pattern to them. The overall fern is the same basic shape as a leaf, as a leaflet of a leaflet, and so on. It's the same basic shape. It repeats itself. I even found fractal broccoli, so broccoli is good for something after all. You see how it repeats it? Let me zoom in a little bit. You see, you got a cone, and it's made up of littler cones, which are made up of literal cones. And isn't that interesting? Wild. Coastlines have a fractal type shape. Now, these are the ones that don't repeat exactly, but they branch, and they branch into smaller branches and smaller branches, and so on. And so that has a fractal property. The way mountain chains look is fractal often. The way they branch. Clouds are often fractal. You can't tell, am I zoomed in on a really small section of a cloud, or am I looking over at most of the sky? You can't tell because the same basic pattern repeats at smaller and smaller scales. The way lightning fragments is fractal. Is this lightning, or is it just a little spark? Well, in this case, you can tell only because there are buildings in the background. But if I did the same experiment with a little spark, it would branch the same way, pretty much. You can't really tell. And so the way lightning branches is in a fractal pattern. Isn't that spectacular? And it's even cooler to watch it in slow motion. You can actually watch it branching out into that fractal pattern. Really quite stunning and amazing. There it goes. Branching out and branching into branches and branching into branches and branches until one of the leaders hits, and then most of the current goes down that leader. So here's my question then. Why do fractals occur both in math, which is abstract, not made up of atoms, and the physical world, which is physical and is made up of atoms? Why do we have fractals in both? Same designer, yeah. That would make sense of it, wouldn't it? So here we have a fractal that only exists in the abstract world of mathematics. You can't find that anywhere in the physical universe, but that one you can. They're very similar. Now this one, that's part of the Mandelbrot set. That exists nowhere in physical reality, but that one does. Isn't that interesting? This shape right here, it's called a Barnsley fern. You're probably thinking that's a real shape. It isn't. That's a mathematical graph. Yeah. And the entire shape, each of these leaflets is the same as the entire shape. And I'll prove that to you. Watch the entire shape here. It goes down and becomes one of its own leaflets. You see that? Yeah, let me do that one more time just because it's cool. Isn't that neat? So each one, it repeats itself infinitely. So that exists nowhere in the physical universe, but that does. Isn't that interesting? That shape, built up into math, it doesn't exist anywhere physically, but that exists on your windows in the winter. That particular shape is a mathematical graph. It does not exist in physical reality, and this, unfortunately, does. This is part of the Mandelbrot set. It's one of those double spirals that we zoomed in on earlier. It exists nowhere in the physical universe, but that I've seen with a telescope. Isn't that interesting? You got fractals occurring in abstract and also made up of atoms. Why is that? And of course, the answer I'm going to lean toward is because God's mind is sovereign over the entire universe. Now, one answer that people might give would be, well, the physical universe obeys mathematical laws, right? So if something can occur in math, it stands to reason it can occur in the physical world because the physical world obeys math. And that's true, but it just pushes the question back, because now I'm going to ask, why does the physical world obey math? That's what I want to know. Why does the physical universe obey math? Well, in the Christian worldview, I can make sense of that. Mathematics are a reflection of God's thoughts, and the universe is upheld by the mind of God. So naturally, we'll see mathematical patterns in nature. It stands to reason in the Christian worldview. God upholds all things by the word of his power, and in him all things consist or hold together. Since God thinks mathematically about things, naturally the universe will be upheld in a mathematical way. But the secular worldview cannot answer that. Try it sometime. Ask an evolutionist, why does the physical universe obey mathematical laws? Now, they take it for granted that we all know it does. But why? You can't make sense of that in the secular worldview. The secular worldview cannot make sense of the properties of laws of mathematics, the fact that they're conceptual and yet existed before human minds, the fact that they're universal, apparently, we assume they're the same everywhere, that they're invariant, they don't change with time, that they're exceptionless, We can make sense of those properties. That's consistent with the mind of God. And the secularists cannot explain why the physical universe is compelled to obey mathematics. But we can, because God is sovereign over the physical universe. It makes sense in the Christian worldview. Don't believe me that secularists can't explain this? We have a physicist here, Eugene Wigner, bright guy, and he wrote a wonderful article that I would encourage you to read called The Unreasonable Effectiveness of Mathematics in the Natural Sciences. The unreasonable effectiveness of mathematics in the natural sciences. He's trying to explore, apparently from a secular perspective, why it is that the universe obeys math. And what is his answer? It's difficult to avoid the impression that a miracle confronts us here, or the two miracles of the existence of laws of nature and of the human mind's capacity to divine them. It's amazing enough, he says, that the universe obeys these wonderful laws of nature. And it's even more amazing that they happen to be in nice, neat mathematical equations like E equals mc squared that the human mind can understand. It's remarkable. And his conclusion in the article is, the miracle of the appropriateness of the language of mathematics for the formulation of laws of physics is a wonderful gift which we neither understand nor deserve. He doesn't have an answer in his worldview. Isn't that interesting? He's a bright guy. He's a physicist. The secularists have no explanation for that. Isn't that interesting? They can come up with evolutionary stories for fossils and genes and so on, but they've never come up with an evolutionary story for math because math can't evolve. It's there, and it's a problem for their worldview. They need it to survive. They have to live in God's universe, even though they might deny God. But they don't have any explanation for it in their own worldview. So we've seen there's a secret code of amazing beauty and complexity built into numbers. That's what I want you to take away. Numbers have incredible beauty and complexity built into them. Maps of certain very simply defined sets, like z squared plus c, show infinite complexity and tremendous beauty when you map them on that plane. Human beings did not create the complexity in fractals. We merely discovered it. It was there all along. Computers did not create the complexity in fractals. They merely helped plot it. You could, in principle, do this all manually. It'd take forever, but you could. The intricacy of fractals is built into mathematics by God. That's the only explanation that makes sense. Fractals have no reasonable explanation in a secular or evolutionary worldview. You just can't make sense of them in that worldview.
So I talked to that NASA scientist today, and he was blown away by this. He knew about the Mandelbrot set, but he said never in any scientific papers, journals, research had he ever heard anything like this. And he said he had to agree with the outcome that was given here because he doesn't know of any secular worldview or explanation that answers why that's the case. And it made me think of Romans chapter 1, verse 18. People suppress the truth, for since the creation of the world, God's invisible qualities, his eternal power and divine nature, have been clearly seen, being understood from what has been made, so that people are without excuse. We talked about this when we looked at the Hubble telescope's images. How can you see some of these things and not wonder or not even believe in a creator? It blows my mind. I hope during this time you did see what difference this view into God's creation can make in your life. Do you have an idea where you might see the laws of God or God's laws in a new way? Do you see where this can create an opportunity to share your faith? I had the 8th graders doing it and I never asked them to. They were telling their friends, and people were emailing me asking me for the YouTube video link, which I can get for anyone who wants it. Did this talk shed more light on how much God loves you? I mean, he has a plan, he has laws, he has math, he has everything in place. I mean, it would be horrible if we really were created in a chaotic universe by chance, because we could never count on anything. But we have these beautiful laws that God has set up for us to be able to trust. So I'll leave you with 2 quotes and a math problem. Science without religion is lame. Religion without science is blind. Albert Einstein. Smart guy. This one was cute. Before creation, this is for you math guys and girls. Before creation, God did just pure mathematics. Then he thought it would be a pleasant change to do if some applied. So some of you get that. And this, the most important math problem ever solved. 1 cross, 3 nails, forgiven. All right, everybody, that's it. Go ahead and head back to your tables. You can email me if you want any of the links. Go ahead and discuss the questions if you like, or if you don't like the questions, come up with some of your own. They're just food for thought. Thank you.